Hello again, everybody, and welcome back. This is, I posted a final exam yesterday. I uploaded it to Noodle, so this is the final exam, part one, the review. Now, this video was supposed to have been done before the final was posted, but due to the chaos of the past 10 days or 2 weeks or so, it's here now. So this is the final, and I'm just going to go point by point. Numbers 1 and 2 are average rate of change. Average rate of change. And all it is changing y over changing x's, or f at, x2 minus f at x1 over x2 minus x1. And that's it. That's numbers 1 and 2. And so, I'll give you an interval. You put the greater value of the interval. You put the lesser value of the interval. The function's value. So that's number 1. 3, 4, and 5 are composition of functions. Composition of functions. Composition of functions. It looks like this. Means you have two functions, you put a g into f. So I'll give you two functions, f at x equals, I don't know, x plus 1, g at x equals x squared minus 3, and I'm putting g into f. This means put g into f. So this is x squared minus 3 right here. What the heck is going on? X squared minus 3 plus 1, which is, and then please simplify this, x squared minus 3. And the other way around is, you put f into g. So this is x plus 1 squared minus 3. And then please square that and add the 1, which is x squared plus 2x plus 1 minus 3. There we go. And then one more is you put a number in here. FOG at 3, for example. Well, I'm putting that 3 here in g. Whoops, here in g. Putting the 3 here to get 9 minus 3, that's 6, and then I take a 6 and put it there. So this is 7. So there we go, that's those 3. 6, number 6, 7, 8, what's next? What next? Number 6, 7, and 8, just 6 is equation of a line with 2 points. So you need a slope. y2 minus y1 over x2 minus x1. You need a slope, and then you use the point slope formula where you fill in one of the points here and the slope there. And so that's number 6. That's pretty much 7 and 8. 7 is parallel. It's the same thing. You need a slope. M of the line you're given is equal to the m that's parallel. How's that? The slopes are equal. You're given a line, you get the slope, and then you use point slope formula. And number 8 is perpendicular. And the same thing, you're given 2 points or something. So you got to find a slope given the 2 points. And then the slope of a perpendicular line is 1 over the slope that you get, and that's also negative. Opposite reciprocals. Number 8. Number 9, intersection of 2 lines. I'm just going to let number 9. Intersection of 2 lines. I'm just going to let you do that. That's an algebra 2. You did really well on the test or quiz or whatever, so I'm just going to let you do that. 10, multiplying number 10. Multiplying complex numbers. Just multiplying complex numbers. You could look it up in the book if you want, but here, you multiply the real parts, AC, then you just FOIL, I guess, plus ADI, and then plus BCI, and then here we go. This is BD I squared, and I squared is -1, which means it's AC minus BD. Plus, let's see, we'll factor out the AD plus BCI. It's too much information for final review. You're going to look at it. But especially for a 3-point problem. That's only 3 points. Where are we? Quadratic formula, number 11. Oh, number 11 is graph a quadratic. Tell all about a quadratic. I'll tell you this. The last problems on exam number 1 was this, and you all did very well on it. When I say that, that's generally. But I'm going to give you a quadratic. Here's and I give you an equation, and what I want you to tell me is the vertex, and then there's an axis of symmetry through there, and then I'd like you to tell me that point and this point, whether it opens up or down, and then graph it. And I think we did that. Oh, and then you're going to have to solve for these things. You get the y-intercept and the x-intercepts, which means you may need to use the quadratic formula. I'm pretty sure you're going to have to on number 11. 12, 13 are finding zeros. And these are third degree. Both of them are third degree, and you just factor. Just factor them as well as you can, and you'll find the zeros. The first one, you have to factor out an x. Let's put it this way. Number 12, x equals 0 is one of the zeros. The second one, I think you have to factor it. It's a third degree, and you have to factor out a binomial, actually. 14. I guess we're at remainder theorem and factor theorem? I think. Hang on. Yeah. Remainder theorem. And for that matter, factor theorem. Both of these, and number 16 maybe? No, involve synthetic division. So I'll do an example of synthetic division. And, I don't know, show maybe x minus 3 is a factor of, not a factor. What is the remainder? Because I'd have to make it a problem. Remainder, x minus 3 into, I'm sorry about this, 3x cubed plus 7x minus squared minus 2x minus 5. What's the remainder? This is number 12. Number 13, you have to show it's a factor. You're going to get a remainder of 0 if I wrote it right. If we get a remainder of 0 here, then it's a factor. But, so the reason I did this is bring down, multiply, add. Bring down, multiply, add. So just so you don't forget synthetic division, I'm bringing that 3 down, and then I'm going to multiply and add the rest of the way. 3 times 3 is 9, add 16, 3 times 16 is 48, oh boy. Minus 2 is 46, 346 is 138, 138. Plus 5 is 143. Oh, this is minus 5. Sorry about that. This is 133. Remainder is 133. F at 3. That's another way to put it. Okay, the remainder factor theorem, we're up to 16, I think. 16 and 17. Log exponential equations. And log equations. Please don't make these harder than they are. This is easy. If you go something like this, ln 2x minus 7 equals 4, you just go e to the ln 2x minus 7 equals e to the 4th. And then this stuff, it's just 2x minus 7. E to the 4th, x equals e to the 4th plus 7 over 2. That was pretty quick. And the same with the log equation. You can take the log of both sides. In number 17, you're going to need to know log of A minus log of B is the same as log of A over B. Log of A over B. You don't need to know that. for 17. 18, 19, what are these? What are these? I don't know. How far are we into this? 10, damn it. Oh, darn, sorry. 18 and 19, exact values. For trig. Page 468 will do. You're going to need, let's see, the definition of trig functions, of 6 trig functions. Just a plain definition. Reciprocals. In other words, sine is 1 over cosecant or vice versa. You need reciprocals, and then you need, all scholars take calculus to do those two. What is that, 18 and 19, exact values, you should just look them up. There's no calculators, you should just look that stuff up. And then the last are measures of the angles. Anything you know, we start with 20 to 22 measures. You need all of that plus sine squared plus cosine squared equals 1. The Pythagorean theorem. So you need all of this plus the Pythagorean theorem for 20 through 22. And the last 1 or 2 of them, 23 or 24, you need SOHCAHTOA. You need SOHCAHTOA for 23 and 24. Now, there's one last thing I'd like to mention, because we didn't actually do this in class or on a video. Well, I did it in class. When I had my calculator, inverse trig functions. And this is on a calculator, because the last however many problems I'm asking you to find the angle. So what goes on here, if you have something like sine of theta equals, I don't know, 1/3 or something. Let's make it 1/4. Sine of theta is 1/4. This means theta is inverse sine of 1/4. So what you put in is, that's 0.25, and then you hit this button. Or, wait, your calculus, you'll hit inverse sine, and then 0.25, and it'll give you theta. Note, in degrees or radians, certainly degrees is what we're using. Radians will be what you use in calculus. So there we go. Good luck. That was a little longer than I expected, but that's a review for the final.